I chose the article Achievement Results for Second and Third Graders Using the Standards-Based Curriculum Everyday Mathematics. And I'm probably going to get these names wrong, but it's by Karen C. Fusen, William M. Carroll, and Jane V. Drueck. So a brief summary of this article is, according to the Third International Mathematics and Science Study, the U.S. curriculum is an underachieving curriculum. That's how they started off with. This is a two-part study that wants to see how students in grades 2 using everyday mathematics will fare to other U.S. students and also Japanese students. While in grade 3, we want to see how EM students compare to NAEP students. We are told in the first study we can see that the EM students were more successful in the achievement test compared to other U.S. students, but we were still lagging behind the Japanese students. In study 2, the students using EM did better with problems that involved context or were more conceptual. After looking at both of these studies, it provided evidence that U.S. students could perform better than they might if they were learning from a traditional textbook. So a little background information is EM stands for Everyday Mathematics. This curriculum was designed to incorporate ideas from the NCTM standards. It was based on the belief that children can learn more mathematics with a deeper understanding. This curriculum reflects the constructivist theories of learning. So this includes students working in small groups or pairs, students actively exploring mathematical ideas, and lessons were designed so that students can build upon their substantial informal knowledge by making connections from previous experiences. And we also see that students are asked to invent and discuss solutions that they have come up with. So now that we know what EM, Everyday Mathematics, stands for, the research questions that we were looking at were, how would students in grades 2 using the Everyday Mathematics curriculum compare to regular US students and Japanese students? We also wanted to know, how would students in grade 3 using the EM curriculum compare to NAEP students? There were two different studies involved in this article. The same students were used in grades 2 and 3. In study 1, there were a total of 343 students that were observed. And in study 2, we had 263, and those 263 had also used everyday mathematics in the second grade. Study 1 followed the progress of EM second graders on developing concepts related to whole number and multi-digit computations. So we compared students using everyday mathematics and students from the US and Japan. Study 2 followed the progress of everyday mathematic third graders on their understanding and uses of whole number concepts, geometry, and measurement. So to compare these students, we used results from the fourth NAEP and test data from Wood and Cobb to provide a basis of comparison. Looking at our results of study 1, using the everyday mathematics curriculum showed positive results in the second grade. On the mathematics achievement test shown below, we can see that everyday mathematics students scored higher on most questions than did our comparison US students. We can see that although the Japanese students scored almost perfect on all the items given on the mathematics achievement test, our everyday mathematics students scored between our Japanese and our US comparison students. We can also see that there were only 4 questions that the EM students had a lower percentage on compared to other US students. So looking at that, we can kind of see that this everyday curriculum was beneficial to the students. After looking at the results of our study 1 of second grade students, we're now going to look at the results of our study 2, which was our third grade students. We can see that everyday mathematics students were more successful on problems that were conceptual or involved a context. Everyday mathematics students in the third grade scored higher overall than the third graders in the NAEP comparison group. We can see, looking at our data from our table, that everyday mathematics students scored a higher percentage on every number and computation problem given below. The conclusion of this article shows that students can learn just as well, if not better, when they are not just learning from a textbook or from traditional approaches. The study also shows that teachers can learn how to support such learning through carefully developed curriculum. A couple potential impacts that may occur from the research in this article is that teachers may want to use other methods to teach rather than just from a textbook. And I know that we don't do this anyway, but having more options is more beneficial to the students. We can also see that more research might be done to find out how the trade-offs between this curriculum and others really benefit the students. Before I end this presentation, I just wanted to give you a few things that I found interesting about this article. The authors did not claim that everyday mathematics was the only way or the best way for new curriculum approaches, but that the students seemed to respond well to this curriculum. We could see that through the data that I showed you a little bit earlier in this presentation. I also found it interesting that the everyday mathematics curriculum used a spiral approach so that the information was repeated throughout the year. And I know that as a student, I like that because it's easier for me to remember what we talked about. I just wanted to thank you for watching this video, and I hope you learned some great information about this article.